Hi, this is Dr. Manas Shome, and today I'll be talking about a framework for DevOps and IT sustainability. Now, as for me, I am a Chief DevOps Evangelist, a consultant, and an author in the area of DevOps and SRE. Now, today, if we look at the information technology as an industry, now this industry has been typically consumption driven by the consumption led initiatives of governments, of institutions, of consumers at the end. Now, when we look at this entire ecosystem, sustainability becomes an important paradigm on how we define IT today. Given that we have a set of 17 UN sustainability goals that we are supposed to be meeting in a few years' time, based on the nations that we are operating in, we see that there are quite a few UN sustainability goals which are directly impacted by IT as a paradigm, as an industry. So, if we look at things like economic growth, if we look at the industry infrastructure, building the infrastructure, if we look at sustainable communities and cities being built, disposable consumption and production, climate action, and then peace and justice and strong institutions. So, if we look at these kind of factors today, and if we define IT in a way that aligns to these goals, it directly impacts how we live today and how we live in the future, how our generations live in the future. But then all the defined sustainability goals are directly or indirectly impacted by IT as an industry today. Now, what defines and how we define IT sustainability? That's an important question. Now, when we define IT sustainability in terms of DevOps and SRE, we look at the four pillars of how we achieve that. The first is reduce, second, reuse, third, rationalize, and the fourth is optimize. So, if we look at these four sustainability tenets on how we align with the UN sustainability goals, and if we drive at these, it becomes very imperative, quite imperative, that we are able to achieve a certain state of sustainability and achieve a certain state of alignment with those goals. Now, if you look at all these different factors, now before I get in those factors, two observations. One, when we are using or leveraging DevOps and SRE in terms of sustainability, we look at two aspects. One, how is DevOps as a paradigm, the DevOps pipelines that we define in terms of people, process, and technology are themselves aligned to the UN sustainability goals. The second is how DevOps or SRE as a whole enables the IT pipelines or enables IT as an industry to achieve those sustainability goals. Okay, so there are two parts to it. One is DevOps adopting sustainability perspectives or aspects, and the pipelines, the IT that gets supported by DevOps achieving a set of sustainability perspectives. Now, if we look at reduce, now each of these pillars or tenets are either having a people impact or a planet impact. The profit impact is definitely there. We are not explicitly talking about profit impact here because that is the bottom line of any business or industry. But apart from that, if we look at beside, in addition to profit, if we look at the people and the planet aspect or the impact that it creates, we would look at reduce, we would look at reuse and rationalize and optimize as the important tenets. Now here, if we look at reduce as an important tenet, we see that technical debt, reducing the technical debt across your application and data infrastructure is very important. The second is infrastructure consumption. It's not only CPU usage, but overall consumption for the infrastructure, which obviously leads to lower CPU usage, lower usage of your storage space, etc., etc. Now, both of these have people impact and planet impact. The third one is data replication. So, how well you are able to replicate and reuse data is an important aspect in achieving a certain state of sustainability in terms of both people and planet. The fourth one is rework and human toil. This is primarily to do with how do you do a people impact in terms of sustainability. Coming to reuse, there are again four things that we look at. First, the pipelines across the IT life cycle. What is the impact on sustainability while you are designing and using the pipelines? So there is a people impact and there is a planet impact as well. Second, tests and test beds. So how are you defining your tests? How are you able to reuse your test cases? How are you able to reuse your test beds, right? So those are the important aspects of achieving a certain state of sustainability in terms of both people and planet impact. The third one is automation to reduce toil. So that is more of a people impact that we look at. While we are building in automation, we are reducing toil of the IT teams as you work across the industry. The fourth one is definitely automation to system resilience. Now what it means is the first set of automation of reducing toil is more about people, but when it comes to enabling more of system resilience, using automation to do that has a people impact as well as a planet impact. The third pillar or tenet is of rationalizing things. Now, what is rationalize? There are three things that we look at. The first, technology and tools usage. We are looking at integrated platforms. So, how do you rationalize the different technologies that you are using? There is a lot of technology diversity that is there in across any organization. So, how do you rationalize that diversity? How do you rationalize your tools usage? How do you bring in integrated platforms that helps you rationalize the usage of those technologies and tools? That's the first thing. The second is about application stacks over a marketplace. Can we have different component wise application stacks or composable application pieces that can be used and reused to build larger applications? And will those applications or microservices, for example, can we put on a marketplace so that they become more composable? You bring in app 1, app 2, app 3 and create your larger application and reuse them as required. So can you do that? Okay, it always also actually applies to data and databases. The third one is data spread and big data footprint. So how are you rationalizing the spread of data, the volume of data that you are processing today? Can you do something about it? What about the digital or the big data footprint in the digital world, right? So there is a lot of sensor based data, a lot of noise that comes in. How do you rationalize that? How do you rationalize what you need and do not actually use what you don't need? Okay, how do you dispose that off? So that is about rationalizing the data spread and the big data footprint. And the fourth tenet is about optimizing. So there are again three things that we look at. The first is data center versus the cloud spread. So as businesses define themselves, there has been concerns about security, there has been concerns about costs of ownership around how do you manage your IT. Now, when you look at data centers versus your cloud spread, you need to optimize the usage across both these areas and also balance them. So that is about optimizing data center vis-a-vis the cloud spread. This has both a people impact and a planet impact. The second one is people structures and interaction. So how do you enable better structures, better people structures and interaction, collaboration between them? So there has to be a balance between what you build as platforms as a service or X as a service, everything as a service, versus how much people actually collaborate within each other in a manual, in a human manner, right? So that is the second part of things which has a lot of bearing on the people impact. The third thing is obviously, and the last thing here is about the process flow. How do you optimize your entire IT process flow, reducing your IT cycle time, for example, reducing a lot of overheads, the work in progress across each stage of your process. This has a bearing on your people as well as planet impact. Okay, so these are quite a few important tenets that we had built upon our IT sustainability based green IT or green DevOps as we call it today. Now, while we look at the different getting into a depth of what we do across all these four different tenets are these. So if you look at the DevOps and SRE levers, we are essentially under reduction. What do we reduce? We reduce technical debt. We put in a lot of tests and code checks on the pipeline itself so that you have a lot of things taken care on your pipeline earlier, the better, right? The second one is containerization and automated resource orchestration. How well are we doing it? The third one is about closed loop automated pipelines along with rollback facilities so that you don't have to do a lot of manual toil while you are rolling back, while things are going wrong when you are deploying things. The fourth one is about metrics driven monitoring of resource usage. So how well you are defining and establishing your metrics so that you can monitor your resource usage possibly in real time. The next one is about automated patch management on pipelines. This becomes an important aspect because every time you need to do a patch, either a security patch or an upgrade, etc., can it be done over a pipeline? Can certain decisions be made using intelligent automation? Today we are talking about Gen AI. Can we use that to actually manage those kind of things? Reducing MTTR, mean time to repair, with AI ops and traceability. How well can we do that? Coming to reuse, we are looking at a few things. We are looking at centralized DevOps and SRE factory-based model, which is for lean engineering. Can we centralize those kind of operations and percolate them across the industry, across the company or the organization we are working for? Why? Because the more fragmented you are, it becomes very hard to actually reuse things, rationalize things. The more centralized, at least to a certain extent, it is, if the governance actually is centralized, it becomes easier to deal with a lot of variations across your organization. The next one is about use of platforms X as a service, which renders a lot of reuse across components. Reuse of data and test beds across pipelines. We have briefly touched upon it in the last slide. SRE-led observability and capacity allocation. Why SRE-led is because we are looking at continuous improvements in terms of system reliability and resilience. And the last one is about service-based applications. How do we get in the concept of marketplace? How do we get in a concept of low-code, no-code kind of paradigm so that the business can also get actively involved when you're designing your applications? The next tenet is about rationalize. We are talking about alert rationalization, policy as code, and AI ops. So those are the things that help you rationalize how you do your alerts. Too much of false positives actually doesn't help. For example, can you rationalize the alerts? Can you, for false positives, if there is a lot of sleepless nights that your operations are spending, that's an impact on people toil. Can we do something about it? The next one is about consumption pattern-led cloud strategy. How do we look at cloud strategy? How do we use intelligent automation, AI, Gen AI, etc., to look at the consumption patterns and define and redefine your cloud strategy in real time? SRE-led IT lifecycle analysis. Can we do an IT lifecycle analysis on a continuous basis? Now, a lot of things, if you look at these points, actually point to a very agile enterprise architecture as a paradigm coming in, right? So rationalizing MLOps pipelines for AI-based systems. How do we do that? Because if you look at traditional AI as an industry, as an important component of IT, AI consumes a lot of resources when they run. So how do we rationalize itself? AI rationalizes itself. Optimizing, it's about predictive visualization of target state IT. We are looking at optimizing the people, process, and technology architectures, reducing the overall cycle time, reducing a lot of things, increasing quality of software, increasing a lot of reusability. Then consumption-led data center usage versus cloud. So when you are balancing your data center versus cloud usage, how can you make it more consumption-led, more real-time? Can we do that? Can we use intelligent IT, intelligent automation to do it? The last one is about optimizing your sensor-based data using policy as code. So there is a lot of sensor-based data noise that we are also talking about. Now, how can you optimize the sensor-based data using policy as code? It's kind of a borderline between you rationalize and optimizing goals, right, for sustainability. So those are important things that comes to as a framework when we are talking about DevOps and SRE levers for achieving a set of sustainability. Now, going over to the ease of implementation versus impact. So how do you look at all these four things, the four tenets that we just defined, into how easier or difficult it is to actually implement versus what is the kind of impact they have. So if you look at reduce, the term of impact may be a little low because it's very quick, very near term, right? But the ease of implementation is very high. So for a quick win, you may want to reduce certain things, the way we have looked at those tenets, right? Then comes reuse. The ease of implementation is a little difficult, possibly not difficult, I would say, but may take more time when it comes to reuse. So because you have to build a repository, you have to build components, you have to design components in a way that they can be reused. But then the term of impact is somewhere in the middle, right? The next one is about rationalizing. The more you're able to rationalize, the term of impact actually increases. Okay, the timeline of impact, right, on people, on the planet, etc., increases. There is a lot of impact if you're able to rationalize quite a few things across your enterprise, across your organization. But it takes a lot to actually implement them. The ease of implementation is fairly higher, fairly lower in that way. Next is about optimizing. Optimizing resource utilization, optimizing a lot of things actually has the highest impact, but long term impact definitely. But then the ease of implementation is pretty low, because to optimize you have to look at the entire industry, you have to look at the ecosystem you're operating in, you have to look at a lot of different things apart from what you are just doing from an IT perspective. So that is about the ease of implementation versus impact. As we go along, we are looking about the framework at the framework itself. Now we defined the framework in our own way. There is a set of questionnaires where we definitely excuse me, automatically capture certain aspects of how these tenets are being practiced today. And based on the practice of those tenets, we are looking at generating a few things out of the framework. We look at generating the carbon footprint scores. We look at generating and using the portfolio-wise heat map to identify hotspots and prioritize the sustainability journeys. The third one is about getting insights to your own sustainability objectives and metrics. And the fourth one is about tracking and improving using continuous automated scoring. So how do we track and improve the overall journey of your sustainability using an automated continuous scoring mechanism? Can we build a near real-time kind of a framework with a set of dashboards that can tell you at any point of time how you're performing on the overall journey, right? So those are the few things that are becomes very important. But then the primary thing that we actually talk about is generating the carbon footprint scores across portfolios, which is the baseline of how do we generate and use our heat maps, identifying hotspots, prioritizing the sustainability journeys, and then deducing what kind of metrics should we be looking at, driving at, to maintain, to achieve a set of sustainability goals. Now having said that, now I couldn't actually bring in the actual dashboard that we actually use for our own customers, the different organizations we work with. So I did a fair handmade representation. I possibly I won't say whether I was a painter or an artist, but then I did kind of handmade representation of what this dashboard at a very preliminary level may look like. There is definitely a kind of data architecture and application architecture that goes behind building this kind of a dashboard, but I'm not going to delve into those architectures. That will be a very detailed discussion. So if I look at the handcrafted dashboard that you see on my screen now, we are looking at the carbon footprint, say for a specific portfolio. We say pick up a portfolio called P8.0. Okay. Now we are looking at the IT sustainability dashboard, which is DevOps driven. Okay. So what are the things that are DevOps and SRE driven that we can bring in? If we build this kind of a dashboard, we are looking at the carbon footprint for the portfolio. Now if you look at how we define sustainability goals, there are three scopes that we typically define, right? We talk about scope 1 sustainability, we talk about scope 2, and we talk about scope 3 based on the kind of direct or indirect impact that your sustainability measures are actually able to help you in the sustainability journey. So scope 1 means it has a direct impact. You are making a direct impact through your business, through your organization, onto your sustainability goals for the environment, for the planet, for the people. So if we look at the here, we are giving, there is a drop down at the top which talks about the scope 1 directives, the scope 1 measures that we have brought about for this particular portfolio. Now there is a carbon footprint that we compute using certain algorithms. Now based on the carbon footprint that gets calculated, there is across all these portfolios, we draw a portfolio heat map. Now there is a representative heat map that comes at the bottom here, on the bottom left, that you see. Say for example, for portfolio 1, portfolio 2.2, portfolio 4 and portfolio 8.5, we are defining the heat map at different levels, right? So heat map shows the carbon footprint at a certain percentage. Now, for our portfolio in this context, portfolio 8.0 has a carbon footprint of 70%, which is pretty high. But then, a rather high carbon footprint here means it is not very good from a sustainability perspective, right? But then it needs to be reduced. If you look at 8.5, it is definitely higher than our P 8.0, which is if you look at the bottom, it is 8.5. 4, 2.2 and portfolio 1 as you go up are doing fairly better than your portfolio 8.0, which is in context here, right? So this portfolio heat maps helps you to prioritize a lot of things on which ones you want to take off first and drive things. But then you can actually add the level of complexity that it takes for a portfolio to achieve a set of sustainability goals. We have not added that yet in this first level report that we are showing you, but definitely advanced level reporting actually shows how complex or how difficult it may be to achieve at a set of sustainability goals for all these different portfolios in the heat map. Now, on the right hand side, what you see are the pipeline characteristics of this particular portfolio, application wise or database wise, for example, or maybe pipeline wise, or you may also define it infrastructure wise. So, for application 1 for this portfolio, okay, which you can select as a drop down that you see, there are quite a set of parameters that we have defined, which in turn defines all those different tenets of your sustainability. So for example, how well you are doing your tech debt control, how well you are doing your container management, how well your CPU usage is done, production traceability, test data reuse, test bed reuse, or cloud usage, for example. So there are several more tenets. There is a scroll box that you see here, which talks about the different parameters that defines all these different tenets. We could have defined in the higher level reports, we actually give a tenet wise view of where you are from a reuse, reduce, or rather reduce, reuse, rationalize and optimize perspectives. But then at a very preliminary level, we do not give that view. What we do is we typically, based on the pipeline characteristics, we draw upon a carbon footprint view that helps to actually identify the quick wins. For example, here, if you look at the center of this dashboard, we are actually talking about reducing the tech debt with bringing in better traceability across your pipelines to be the quick win, based on which can be achieved very fast. Okay, so definitely it's about reduce. So you have to reduce your technical tech debt the way we looked at the tenets in the previous slides, and in turn also improve your traceability. So those becomes important at the first moment. The second thing may be something that you want to tackle from a reuse perspective. The next would be rationalize, and next would be the optimizing part. So this is how we have defined this dashboard. Now, what are the key benefits that we have realized when we have come in and started doing this kind of an exercise with our customers with this kind of a framework? We are looking at, actually have realized around 18% or higher reduction in carbon footprint on inefficient CPU infrastructure and storage usage. That is pretty significant. 18% has been pretty significant. When we started, it was pretty low. As we had been on this kind of a journey with our customers since the last 1 year or year and a half, or maybe a little more, we saw that the efficiencies actually started scaling, right? So the more you do it you start with one quick portfolio, then you percolate it across the rest of the portfolios, things start scaling. Next is about 30% or higher savings in rework, people toil, and better quality of life for teams. Definitely, this is the people impact. The third one is about 15% outright efficiencies due to rationalization and optimization of the resource utilization. One shun leading to another shun leading to another shun. So rationalizing, optimizing what? Rationalizing what? Optimizing what? Your resource utilization. So that gives a 15% outright efficiencies. The fourth one is about high enterprise scalability and optimized people utilization. So that brings in a lot of leverages on what are the kind of sustainability goals you're trying to achieve in terms of reducing people toil, giving better quality of work life to your employees, to your larger ecosystems, right? With revamped team structures. So that is an important aspect. We look at team structures, we look at people architecture. We actually have defined people architecture as code. Can we do that? We have intelligent automation to do that today. Then the last one is about 12% or higher cost savings in IT that can be utilized in regenerative capabilities. Building regenerative capabilities is something that I'm not explicitly talked about, but definitely while you rationalize and optimize on a longer term, those are important aspects that you can bring in. And we have seen a lot of cost savings coming out of saving your costs in the mainstream IT itself, right? So those are the key benefits that you can realize. And with that, I come to the end of this presentation. And I hope you enjoyed. I hope it adds value to how you're driving your sustainability goals. Thank you.